the integral of y sine xy over the following rectangular area. So the surface is the following, and we'll be finding the integral of that. So first, I'm going to do this integral with respect to x first and then y. So let's rewrite this as iterative integrals. So y sine xy. So I'm going to do it integral with respect to x first and then y. So the limits for x, it's from 1 to 2, and limits for y from 0 to pi. So if I do the integral with respect to x first, so this part of the integration. So that's 0 to pi. This integral will be negative cosine xy, because when you take the derivative of cosine, it's negative sign. So with this negative sign, that becomes positive. And then you have to do chain rule that puts this extra y in front of the function. So that's from 1 to 2 dy. And then from 0 to pi. So that gives me cosine, negative cosine 2y. Subtracting cosine y means adding just cosine y dy. And now this is a single integral with respect to y. So let's do the integrals. The integral of negative cosine 2y is again negative sine 2y over 2. We have this 2 because of chain rule. When you take the derivative of sine 2y, you'll have extra 2 in front of it. So that's this extra. And then plus sine y. So derivative integral of cosine is sine y. And that is from pi to 0. So if I plug, so that's an interesting point. If I plug pi into the function, so negative sine 2 pi over 2 plus sine pi. Here both of them are zeros. So this is 0 and this is 0. And then if I plug just cosine y is equal to 0, negative sine 2 times 0 over 2 plus sine 0. So that's again 0. So the final result for this problem is 0.